Hello everyone and welcome to the YouTube channel of Artificial Intelligence and Data Science Department of TSEC. My name is Vishesh and today's video is about neural networks. Before understanding neural networks, let us see how the human brain actually works. So, the human brain consists millions of neurons which are interconnected to each other. These neurons try to recognize patterns on anything that we see or experience. For example, let us consider a baby who is trying to learn about foods. Until now, he has no knowledge of any kind of food. If he sees a fruit, let's say apple, a multiple amount of time, his brain will try to create a pattern inside. What this will do is, the next time he sees an apple again, his brain will analyze that this fruit is an apple. The artificial neural network works in a similar way. The neural network is given a set of data, and based on that data, it tries to create a pattern inside of it. So whenever the next time it is provided with a set of data, it gives an output or a prediction of what the data is like. The artificial neural network mainly consists three types of layers. The first is the input layer, the hidden layers, and the output layer. The input layer consists of all the data that we are going to give to the neural network, and the output layer consists of the predictions that the neural network has made. Let us consider an example. If we are giving a data set of apples and oranges to the neural networks, the data set would lie in the input layer, and the output layer, that is the prediction whether a new image is an apple or an orange, lies in the output layer. The hidden layer is responsible for determining patterns within the data that we had given to the neural network. For example, the first hidden layer may be evaluating the shape of the fruit, and the second hidden layer may be evaluating the color of the fruit. Based on those patterns, the output layer gives the output for the new image. Now, we notice that depending on the inputs, different neurons are being activated. These neurons further activate other neurons onto the next layer, and we can clearly see that the information or the input that we had provided to the input layer is being propagated forward until the output layer, and then the prediction has been made. Therefore, this step is known as forward propagation. Once the output has been generated, the output is compared with the actual result. And if the result turns out to be wrong, the network goes in a backward format in order to correct the weights that it had gone wrong and in order to correct the pattern. Since we are going backward in this, it is known as backward propagation. Since we have already learned what a neural network is, let us move on to a further topic. GAN, or Generative Adversarial Network. Consider a scenario where you want to create an image of an apple from scratch. In such cases, GAN or Generative Adversarial Network can be used. The GAN mainly consists of two modules, the generator and the discriminator. The generator is responsible for creating the output image, for example, apple. So the generator starts with a very random noise source and tries to create an image which looks like an apple. Then, once the image has been created, the discriminator validates it whether that the image generated by it is an apple or not. If it does not match with an apple, then the logic of back propagation is used and the cycle is followed again. This cycle continues until the generator is able to create an image that almost looks like an apple, and the discriminator consider it as a real apple. That's it for today's video. Do like, share, and subscribe to our YouTube channel and stay tuned for further videos. Thank you.